Remote sensing is any technique used to acquire the information about the object without any physical contact with the object. The source of remote sensing data is the electromagnetic radiations which are emitted or reflected by the object, which then helps in their identification and classification. Electromagnetic energy produced by the vibration of charged particle travels in the form of waves through the atmosphere and the vacuum space. These waves are classified depending on their frequencies. Visible light sits in the middle of that range of long to short wave radiations. This small portion of energy is all that the human eye is able to detect. Satellite instrumentation utilizes the full range of spectrum to explore and understand processes occurring here on Earth and on other planetary bodies. The output of a remote sensing system is usually an image representing the scene being observed. A further step of image analysis and interpretation is required in order to extract useful information from the image. The human visual system is an example of a remote sensing system in this general sense.
Remote sensing may be split into two types: active remote sensing and passive remote sensing. In passive remote sensing, sensors gather radiation that is emitted or reflected by the object or surrounding areas. Reflected sunlight is most common source of radiation measured by passive sensors. Examples of passive remote sensors include film photography, infrared, charge-coupled devices, and radiometers. In active remote sensing, on the other hand, a source emits energy in order to scan objects and areas, whereupon a sensor then detects and measures the radiation that is reflected or backscattered from the target. Radar and LiDAR are examples of active remote sensing where the time delay between emission and return is measured, establishing the location, speed, and direction of an object. In current usage, the term remote sensing generally refers to the use of satellite or aircraft-based sensor technologies to detect and classify objects on Earth, including on the surface and in the atmosphere and oceans based on propagated signal. Remote sensing satellites are equipped with sensors looking down to the Earth. They are the eyes in the sky constantly observing the Earth as they go around in predictable orbits. There are three primary types of orbits in which satellites reside: polar orbit, non-polar low Earth orbit, and geostationary orbit.
Polar orbiting satellites are in an orbital plane that is inclined at nearly 90 degrees to the equatorial plane. This inclination allows the satellite to sense the entire globe, including the polar regions, providing observations of locations that are difficult to reach via the ground. These orbits can be ascending or descending. In ascending orbit, satellites are moving south to north when their path crosses the equator. In descending orbit, satellites are moving north to south. Polar orbits are often used for Earth mapping, Earth observations, capturing the Earth as time passes from one point, reconnaissance satellites, as well as for some weather satellites, such as the Xiaomi National Polar Orbiting Partnership that provides daily coverage of the globe. The disadvantage of this orbit is that no one spot on Earth's surface can be sensed continuously from a satellite in a polar orbit. Non-polar low Earth orbits are at an altitude typically less than 2,000 km above the Earth's surface. For reference, the International Space Station orbits is at an altitude of 400 km. A low Earth orbit requires the lowest amount of energy for satellites placement. It provides high bandwidth and low communication latency. Satellites and space station in LEO are more accessible for crew and servicing. The Global Precipitation Mission is an example of a non-polar low Earth orbit satellite covering from 65 degrees north to the 65 degrees south. These orbits do not provide global coverage but instead cover only a partial range of latitudes. Satellites in low region of LEO also suffer from fast orbital decay, requiring either periodic reboosting to maintain a stable orbit or launching replacement satellites, and old ones re-enter to the high drag atmosphere.
Geostationary satellites follow the Earth's rotation and travel at the same rate of the rotation. Because of this, the satellites appear to an observer on the Earth to be fixed in one location. These satellites capture the same view of Earth with each observation and so provide almost continuous coverage of one area. Communication satellites are often placed in geostationary orbits so that Earth-based satellites antennas located on Earth do not have to rotate to track them, but can be pointed permanently at the position in the sky where the satellites are located. Weather satellites are also placed in this object for real-time monitoring and data collection. One such satellite is the Geostationary Operational Environmental Satellites (GOES). Navigational satellites are also in geostationary orbit to provide a known calibration point and enhance GPS accuracy. Whether it be satellite remote sensing, radar, LiDAR, or human visual system, remote sensing is an everyday essential, easing human time and effort.